Nobody tells you this in school. Nobody puts this in the textbooks clearly enough. But the universe, the actual, real, measured universe, is so unimaginably large that the speed of light, the fastest speed anything can travel, is almost embarrassingly slow compared to it. Light takes 100,000 years just to cross our galaxy, our one galaxy, out of 2 trillion, and this is the thing that stops alien visitors cold. Not their technology, not their will, not their curiosity, the sheer, merciless, indifferent size of the place they would have to cross. Size so extreme it turns millions of years into a short trip. I want to show you what I mean, and I promise by the end of this, you will never think about the universe the same way again. Let's start small and work our way up, because the only honest way to understand how big the universe is to climb the ladder of scale one rung at a time. Otherwise, the big number at the top doesn't land. It just sounds like any other big number. And it isn't. It's something else entirely. Start with Earth, our home. About 8,000 miles across. If you drove around the equator at highway speed, it would take you about 2 weeks. That's manageable. That's a road trip. Now go up one level. The moon is about 239,000 miles away. At highway speed, that trip takes about 6 months. A little long for a road trip, but still a single number your brain can process. The sun is 93 million miles away. At highway speed, 177 years. Starting to get uncomfortable. But light does it in 8 minutes. So light is helping us out here. Now here's where the ladder starts to feel unstable. The nearest star beyond our sun is Proxima Centauri, about 25 trillion miles away. Light takes 4.24 years to get there. Our fastest spacecraft after 50 years of flying hasn't even covered 1/10% of that distance. We are not even at the bottom rung of interstellar travel. We are still on the ground looking up at the ladder, but Proxima Centauri is just the nearest star. It's the one right next door. In our galaxy alone, there are estimated to be between 200 and 400 billion stars, 2 to 400 billion suns, each separated from its neighbors by distances measured in light years. The average distance between stars in our galaxy is about 5 light years. 5 light years of empty space between neighbors across 200 to 400 billion of them, arranged in a spinning disk about 100,000 light years across and 1,000 light years thick. That is our galaxy. One galaxy. And it would take light moving at 186,000 miles per second without stopping, without slowing, without rest, 100,000 years to cross it end to end. A spacecraft moving at 1% of the speed of light, which would be incredibly fast by any human standard, would take 10 million years to make that crossing. 10 million years. The dinosaurs went extinct 66 million years ago, so we're talking about a journey that a generous 1% of light speed takes longer than 1/6 of the entire age of the non-avian dinosaurs' reign on Earth. And that is just our galaxy. We haven't left yet. Now take a breath, because this is where it gets truly staggering. Beyond our galaxy, there are more galaxies. Many more. The observable universe, the part of the universe we can actually see with our best telescopes, contains an estimated 2 trillion galaxies. 2,000 billion separate galaxies, each containing hundreds of billions of stars. The nearest large galaxy to ours is the Andromeda Galaxy. It is about 2.5 million light years away. That means the light reaching your eyes if you looked at Andromeda tonight left that galaxy 2.5 million years ago. When that light began its journey, Homo sapiens didn't exist yet. Our ancestors were early members of the Homo genus, still learning to chip stone into tools. That light has been traveling through space for our entire evolutionary history and only just arrived. To send a spacecraft to Andromeda at 10% of the speed of light, which is far beyond anything we can currently do, would take 25 million years, one way. And Andromeda is our neighbor. Now multiply that by 2 trillion galaxies, spread across a volume 93 billion light years in diameter. That's the size of the observable universe. And you start to grasp what too big really means when I say the universe is too big for alien visitors. It isn't poetic. It isn't an exaggeration. It's a measured, calculated fact. The universe is so large that even the most optimistic physics we know allows only the tiniest fraction of it to be accessible to any civilization, no matter how advanced. And here is the part that makes this even harder. The universe is expanding. Edwin Hubble discovered in the 1920s that every galaxy outside our local group is moving away from us. Not because they're flying through space, but because space itself is stretching. The fabric of the universe is getting bigger, and the farther away a galaxy is, the faster it appears to recede because there's more expanding space between us and it. Some galaxies are so far away that the space between us and them is expanding faster than the speed of light. Not the galaxies themselves, but the space between us. And this means those galaxies are in what cosmologists call the cosmological event horizon. We can see them, their light has already reached us, but we can never reach them. Not ever. Not with any spacecraft, not with any technology, because space between us and them is growing faster than we could ever cross it. Even if we could travel at the speed of light, the destination would always be moving away faster than we could close the gap. This is permanent unreachability, not a technical problem, a physical one, built into the universe at its deepest level. So the universe is not just big. It is big in a way that creates permanent, inescapable regions that can never be visited by any civilization from any other region. The universe contains volumes of space that are causally disconnected, physically cut off from each other forever by the expansion of space itself. And this applies to alien civilizations exactly as much as it applies to us. They face the same expanding universe, the same event horizons, the same permanent separations. Whatever they build, whatever they achieve, they are working within the same cosmic rules. Now let me turn this around and look at it from a very practical angle, because all of this is interesting in the abstract, but let's make it concrete. Suppose there is an alien civilization in a galaxy 100 million light-years from Earth. That's not far by cosmic standards. There are millions of galaxies within 100 million light-years of us. This civilization is advanced. They've been around for 1 million years longer than us. They've solved energy production. They've built the fastest ships their physics allows. And they've decided, for whatever reason, to try to reach the Milky Way at 20% of the speed of light, which is heroically optimistic. The trip takes 500 million years. 500 million years ago, Earth was in the Cambrian period. The most complex life on this planet was soft-bodied ocean creatures and early fish. There were no land animals, there were no trees, there were no flowers, there were no mammals, there were no dinosaurs. None of that had happened yet. That is how long ago a ship would have had to leave to arrive at roughly the right time, and that's just from 100 million light-years away. Not from across the universe, just from our cosmic neighborhood. Do you see what the size of the universe does to travel? It doesn't just make trips long, it makes them so long that the entire geological and biological history of Earth fits inside a single one-way journey. The trip outlasts species, it outlasts continents, it outlasts everything. And this is why I find the question of alien visitors so fascinating to think through, honestly. When you actually do the math, when you plug in real distances and real speeds, you don't get a mystery. You get a very clear answer. The universe is so large that physical travel between most of its civilizations is not just impractical. For most pairs of civilizations across most of the universe, it is effectively impossible within any time frame that makes sense to a biological being or even to a civilization with any kind of continuous identity. Now, some people push back at this point and say, but what about civilizations that have been around for billions of years? What about truly ancient beings that have been expanding for geological timescales? Surely they could colonize slowly, one star system at a time, spreading outward across millions of years? And this is an interesting idea. It's actually one of the more serious proposals in astrobiology, the concept of slow galactic colonization, where a civilization expands at a few percent of the speed of light by hopping between stars, building colonies, and then expanding again from each new colony world. In theory, this could allow a civilization to spread across the galaxy in as little as a few million years, which sounds long but is actually quite short compared to the age of the galaxy, which is about 13 billion years old. So if any civilization started this process even 1 billion years ago, they should have already reached every corner of the Milky Way. They should be here by now. The fact that we see no evidence of this, no megastructures, no signals, no colonized systems, no visiting ships, is itself a profound puzzle. But even this idea runs into the size problem when you scale it up beyond our galaxy. Because galaxy-to-galaxy travel requires crossing the 2.5 million light-years to even reach our nearest neighbor. And during those millions of years of travel between galaxies, the universe continues to expand, the destination keeps moving. The trip gets longer the farther you go, and the energy cost of maintaining a civilization-scale migration across intergalactic distances is beyond anything we can responsibly calculate. So even the slow colonization model which might work within a single galaxy over billions of years, completely breaks down at larger cosmic scales. The universe is too big for it. And here's something else I think is worth saying clearly. The universe being this large is not an accident of location. It's not like we happen to live in a big part and other parts are smaller. Every single civilization in the universe faces the same scale. Every intelligent species, wherever they evolved, looks out at the same vast distances. They all see 100,000 light years of galaxy around them. They all see 2 trillion other galaxies stretching out in every direction. They all face the same math. The size of the universe is a universal condition. It's not a problem unique to us. It's the problem everyone faces. And if that's true, it means that isolation is the default state of intelligent life in this universe. Not connection, not sharing, not the busy interstellar civilization of science fiction. Isolation. Every civilization in its own quiet corner. Surrounded by stars they can study, but not visit. Surrounded by galaxies they can see, but never reach. This idea connects to what cosmologists call the observable universe versus the actual universe. The observable universe is the region from which light has had time to reach us since the Big Bang. That's a sphere about 93 billion light-years in diameter, centered on us. But the actual universe, the full extent of everything that exists, may be vastly larger. Some models suggest it could be hundreds of times larger than what we can observe. Others suggest it might be infinite. If the universe is infinite, then the number of civilizations is possibly infinite too. And an infinite number of civilizations, all isolated by the same crushing distances, all unable to communicate meaningfully across most of those distances, that is a picture of existence that should give every curious person a long moment of quiet thought. We are not special in our isolation. Every other civilization is equally isolated. The universe doesn't play favorites. It applies its rules to everyone. Now I want to come back to something practical and hopeful, because all of this talk of size and isolation can start to feel oppressive. And I don't mean it to, because there's something remarkable hiding inside this problem that I think gets missed. The universe, for all its size, sends light to every corner of itself. A photon released by a star 10 billion years ago will travel forever if nothing stops it. Light doesn't care about distance. It doesn't slow down. It doesn't get tired. It just goes, and that means that every civilization in the universe has access, slow, ancient, delayed access to the light of every other part of the universe. We look at a galaxy a billion light years away and we see it as it was a billion years ago. That is not nothing. That is an enormous amount of information. Cosmologists have used that information to figure out the age of the universe, its composition, its history, how it expanded, how galaxies formed, how stars live and die. We've built a detailed history of the cosmos going back to within fractions of a second of the Big Bang, all from light, and any civilization looking at us, if they're close enough to have received our light, is learning from us too. Our spectrum, our chemistry, whatever signals we've sent, it's all radiating outward at the speed of light right now. Silent ambassadors made of photons, crossing distances we could never cross ourselves. So while the size of the universe prevents visitors, it does not prevent witness. The universe is full of witnesses. Every star witnesses, every other star through the light that crosses between them. Every civilization witnesses the universe it finds itself in and potentially witnesses others, slowly across time through the study of light. That is not nothing. That is extraordinary. That is, in a very real sense, a kind of connection, delayed, one-directional sometimes, ancient by the time it arrives, but real, physical, measurable. And we are doing it right now. Every observatory on Earth, every space telescope in orbit, every radio dish pointing at the sky. We are all witnessing the universe, reading it, decoding it, building a picture of everything that is out there from right here without moving an inch. The universe is too big for alien visitors, that is a fact. A hard, physical, mathematical fact that no civilization in the cosmos can argue their way around. But the universe is not too big for alien light. And light, if you know how to read it, tells you almost everything. I think that is one of the most beautiful things I know, that the universe, despite its absurd size, despite its permanent separations and its expanding voids and its unreachable horizons, still manages to connect everything to everything else through light, through information, through the patient transmission of photons across space and time. We are not visitors, we are witnesses, and maybe that's exactly what we were always meant to be. The universe gave us eyes, it gave us telescopes, It gave us mathematics and physics and the capacity to decode the signals arriving at our doorstep from across billions of years of cosmic history. Maybe the universe isn't too big for us after all. Maybe we're just the right size to understand it,